So what is recursion? Recursion is literally when a function is calling itself. Okay? That is what recursion is. But before we talk about what recursion is, we have to talk about something. We have to talk about JavaScript first as a whole. So JavaScript is a single-threaded language. Okay? And that means that JavaScript will run only one function at a time. But if one function is triggering another function call and one and this and that and this and that, how will this language figure out what is running at one point in time if it can only run one thing? That is called the call stack. Okay? I'll show you an example right now. So if I have a function up here, says hi, and it just console.log. So I have these two simple functions up here, says hi and says yo, right? And then down here on line 11, says hi is being invoked and says yo is being invoked. So when I run this page, what is going to happen, this thing that you can't see, the call stack, it sees that this function says hi is going to run. So that function is then going to go onto the call stack, okay? Right when it's invoked, it goes onto the call stack. JavaScript sees the call stack and says, okay, there's nothing above it, so this function is going to run. And then it runs says hi, and then says hi is running is going to run. Then, after it's finished running, says hi is actually removed from the call stack. It's gone. It's not on the call stack anymore when this is done running. And then when it's done running, we can go to line 12. And then another function is invoked. And then that function is then thrown onto the call stack. Then JavaScript says there's nothing above it, so this is the only thing we're going to run. So then says yo runs, and then when it's finished running, it gets taken off the call stack. So you can see that these things are running in that correct order, right? It's not really that hard of a concept to kind of understand. It's like when a function is running, it goes onto the call stack. When it's done running, it goes off of the call stack. Is everyone with me? Does anyone have any questions about what the call stack is, how it works, anything like that? This is sort of a behind-the-scenes mechanism that the actual language uses to understand which function is running at what point in time. So, now I will show you something else. So let's say we're going to write a function that takes in a number, and it's called countdown. And what we're going to want to do is we're going to console log that number down to 1. Okay? And then at the end, we'll say done. Okay? So we could just write a for loop, right? We set I equal to the number. I is greater than 0. I minus minus, right? So then we can console.log the number. Oh no, we console.log I. Then, after that's done running, we can just console.log done. So, when you invoke countdown, and you pass in 5, you get 5, 4, 3, 2, 1, done. Is this confusing? This is just a simple for loop, right? It's just a simple for loop, reverse, going down, decrementing I, starting at whatever the input number is, and then here we have 5, 4, 3, 2, 1, done. Back to what we said on the call stack, when this is running, that function will actually go onto the call stack, it will run this for loop, it's still on the call stack, it will run this for loop, then, after a console log is done, there's nothing left, the function's done running, so then that function gets taken off of the call stack. Okay? So where does recursion fall into this? So if you think about it, recursion is a function calling itself, right? So you can actually call a function itself to solve this problem as well. You can use recursion, you could solve a problem recursively when you can solve a problem using a loop. They're interchangeable, because you're sort of doing the same thing. I'll show you what I mean. So let's say right away, let's delete this. Well, I'll leave it here just so you guys can see. But like, let's say we'll write another thing, right? And it's not going to do anything yet. Let's say we just do this. What do you think is going to happen if I just do this? When I hit line 27 and I pass 5 into countdown, what's going to happen? Exactly. What is actually happening is when you pass this, when you pass this, when you call this function, countdown invoked with 5 is thrown onto the call stack, right? Does everyone agree? I just explained how the call stack works, so that should work the same, right? So then this function started running. JavaScript sees that. So we run this function. Inside this function, we are now going to run countdown, the same function. So then JavaScript says, okay, this thing is on pause, and then countdown, and then we're passing in number here, so countdown, whoops, invoked with 5 is now going to be put on top of that. When a function is on the call stack and then another function is called before that function is finished running, the function that was running gets paused, and then another thing goes on top of it. And then JavaScript will run the function that is on the top of the call stack first, before it finishes everything else. Does that make sense? So this function is paused, the first call, then the second call is running. But you see there's a problem. When countdown is ran again inside here with the same number, it's just going to keep going over and over again. So basically, you get this error. And this error might sound familiar to you guys, right? This happens when you would write a while loop and forget to increment I, right? When you don't tell a while loop to stop. This is the same type of logic, right? You need to tell this recursive function when to stop calling itself. And this is known as a base case. That's just the expression. A base case. A base case. A base case is like saying, okay, when this is this, don't call the function again, right? A quick tip when you guys are solving problems recursively is always define your base case first. Always know when you want the function to stop, right? So let's think about this problem. Let's think about countdown. We're going to throw a number into it. Every time you want to console log that number, and then the next time you want that number to be lowered by 1, right? So how do we get the number to go down? Num minus minus. I'll do num minus 1, so it's more clear. But this still doesn't work, right? Because we still haven't written our base case. But this makes sense now. The first time countdown goes onto the call stack, we have countdown of 5. But then we're calling countdown with 5 minus 1. So this is going to be 4. And then this is going to call it again with 3. Does that make sense? Right? And it's just going to keep going forever to negative infinity. But the maximum call stack size has been exceeded. It's an error, timeout error. No more space, okay? So when do we want, so how can we like say when this to stop? What's like an easy thing to do, right? Just an if statement, right? That could work. So I could say, if something else do, oh, what the fuck? What's going on? Else do this, right? But first, before we call it again, we're going to want to console.log the number, right? So if our base case was not hit, we're going to want to console log the number and then call the function again with the number 1 less. So up here, when did we stop? We stopped at 1, right? So we can say if num is less than 1. So if num is now 0, if we've already console logged num and you send 1 minus 1 into countdown, so we send 0 into countdown, we're just going to console.log done. And it works the same way. So let me show you step by step what is happening in this function as it interacts with JavaScript's call stack. This is a function definition. Everyone agrees? So nothing is happening right now. But when JavaScript goes down here on line 32, it sees that a defined function is being invoked with the number 5. Right away, 5 is put onto the call stack here. So 5 is running. Countdown with 5 is running. Num is now equal to 5. Is 5 less than 1? No. So this if block is ignored, and we automatically go into the else block. So we console log 5. Then we count down with 5 minus 1. We call that the same function that we're inside of with the same argument subtracted by 1. So then countdown of 4 is put onto the call stack. And 5 is paused, right? So when countdown of 4 is put onto the call stack, we then run this function countdown with num is now equal to 4. Is that greater than 1? Is 4 less than 1? No. So we do the same logic again. We console log it, and then this goes in, but now this is paused, right? And then when this goes in, this is paused. Because then we have to call countdown with 2. And when countdown of 2 is called, 2 is still not less than 1. So we do the whole logic again. We console log the 2, and then we call countdown with 2 minus 1. So this gets paused because something else gets thrown on the call stack. Countdown of 1, right? Is 1 though, is 1 less than 1? It's not. 1 is 1, so we are still going to console log that number, the current number, right? And then we get 1. But after we console log 1, we are now going to call countdown again with 1 minus 1. So now this gets paused. And then this gets thrown onto the call stack. Countdown of 0. So, what is going to happen now? We run countdown where num is equal to 0. Is num less than 1? Yes. We finally hit the base case. So now, in the if, we just console log done. And since this is an if-else statement, if the if condition is run, the else is never going to get hit, right? So when we console log done, we skip the else, and then nothing else happens in that function. So what do functions return if you don't tell it to return anything? Come on, you guys know this one. Undefined, right? So then the results of this function will be undefined. So countdown of 0 is actually returning a value undefined, right? And if countdown 1 returns, so then when that returns, when this is returned, then when countdown of 1 called countdown of 0, this was done, right? This is now done in this situation. Because countdown of 0 is taken off the call stack because it's finished running. It returns something. But now countdown of 1 is no longer paused. Right? And countdown of 0 equals undefined. We have that return value. So then we can finish this. So then countdown of 1 is also going to return undefined. So this is now undefined, because we're not telling it to, this is fine right now, because we're not telling it to return anything. That's just what happens, right? All we care about is what's being console, okay? So then if countdown of 1 is returning undefined, that means countdown of 1 is finished running, right? It ran through the code, that became evaluated, so then this is going to be taken off of the call stack. So countdown of 2 is no longer paused. Do you guys see a pattern? Once you hit the base case and you get a return value, if you're telling it to return something, or if you are returning nothing, you're just console logging, you're still going to get undefined as a return value. So it will then carry that up all the way. So so like I said, then this is finished running, this is now equal to undefined. So it's taken off the call stack, so this is no longer paused. You guys see what I mean? Then, all the way at the end, when countdown of 5 is no longer paused, this is going to be equal to undefined, right? And it is. Are there any questions? Yeah.
If you pause, wouldn't you? So from pausing, you go from coming off the stack rather than restarting. So if it was pause, if it had a value of say 4, why would it then be 4?
What do you mean?
When
When I say pause,
values of 5, 4, 3, 2, 1, why wouldn't it then
when I say pause, it means like when this is invoked with 5, right? When it's invoked with 5, it's running. Because another function is being called before the original function stopped running, that original function can't finish. It has to wait for this other function to run. So that's what I mean by pause. It's on hold because it has to wait for this function to stop running. You know. So countdown of 4 goes on top, and that's where the call stack comes in. It's a visual way to see what's happening. You call a function, it goes here. It runs through the function. Oh wait, there's something else that has to be called. So this can't finish. It can't be removed because when a function is done running, it gets removed off the call stack. So it's still there, but now since another function is called, that's going to go on top. And then this function has to run. And JavaScript only runs one function at a time. That's just how it works. That's how the language is written. It's single threaded.
So it takes twice as long to run that because it's on the stack.
Well, it has to put everything on the stack and then remove everything off. Does that make a little more sense? Are there any other questions? Cool.
Let me just look something up real quick.
Okay. So now I'm going to show you an example actually using the return value. Okay? We're going to be passing that return value all the way back to get the correct number. Okay? So, have any of you math majors heard of the Fibonacci sequence? Okay, well, has anyone heard of the Fibonacci sequence? Whatever. I will go over what that is right now. So, Fibonacci numbers. So the first two numbers of the Fibonacci sequence will be 1 and 1. Then the next number is going to be the previous two numbers added together. So the next number is going to be 2. So the next number will be 3. The next number will be 5, then 8, then 13, and so on and so forth. Does everyone understand? That's what the sequence is. It's just the previous two numbers added together will equal the next number. Except the first two numbers, which are both 1. Okay? So, let's say I asked you to write a function that takes in a number and returns, it returns the, like if I pass in 3, it will return the third number in the Fibonacci sequence, which is 2. If I pass in 5, it will return the fifth number. If I pass in 7, it will return this one. If I pass in 500, it will return the 500 number. Okay? So let's write a function that does that. Let's do that with recursion. So let's say we write a function called gets fib numbers. And that's going to take in a num. Okay. And at the end, we will get fib number. And then we will pass in 6, and that should give us 8. Right? Okay. So like I said with recursion, the first thing to do is start with a base case. So, if we know what I said before, that the number will be equal to the previous two numbers added together, right? So that's dynamic. Those two numbers will be different for everything, except which two places? At 0 and 1, right? So we can say that if the num is less than 2, right? Because we're going to say that you have to pass in 1, 2, whatever. You can't pass in 0. And 1 will be the starting sequence, right? So if that number is less than 2, or should we start at 0? If the number is less than 2, we're just going to return 1, okay? And that's our stopping point. Because the first two numbers have to be 1. So then how could we solve this with recursion then? You know that we have to say get fib number. We have to call that again somewhere, right? But how do we actually do it? Well, this was going to go in an else statement. So, in this case, we will say get fib number. If we want the specific number, what are the two numbers that are added together? Exactly. So we can say return get fig number of num minus 2 plus num get fib number of num minus 1. So then when you call it with 6, I'm 1 on. 1, 2, 3, 4, 5, 6. Oh, I guess it's going to start at 0, right? Because if we started at 1, I think. Yeah, okay. Well, my math is a little off. This will be an array now. So at the 6th index, we'll get 13. Okay? So let's see what's actually going on, right? With the call stack. We call get fib num with 6. Does everyone agree? So this will then go onto the call stack. We call get fib num. So is 6 less than 2? It's not. So now, we're not going to console log something. We're actually going to return something. But what we're going to return is the value of two function calls added together. So the first thing that's going to happen is that we will say get fib number of num minus 2. Num minus 2 is 4, right? So that gets put onto the call stack. This might be not a good problem to show you guys, now that I'm thinking about it. So then that function gets put onto the call stack. Because to evaluate this equation, it has to get the values of both, right? So this, it tries to read what this is first. It goes from left to right. So then this is put onto the call stack, but then it doesn't even get here yet. The whole thing is paused, right? Fib number of 6 is now paused because another function has been called. So then we call this function again. Num is now 4. Okay? Is 4 less than 2? No. So we go into here, and then we return the same thing. So we say, get fib number of 2 is being called here. This statement isn't reached yet, right? It was never evaluated yet, because this is being called. So then we call the same thing again with 2 here. Is 2 less than 2? No, 2 is 2. So now, when we get down here, we're going to return get fib number of 2 minus 2 of 0. Plus, doesn't even matter, we can't even get to that part yet because you're calling another function. We have to find out what this value is. So then get fib number of 0. Now, our base case is going to get hit, right? Because now the number is equal to 0. So if 0 is less than 2, we're going to return 1. So this is going to be equal to 1. But now, get fib number of 2 was on pause, right? So then it's going to be of 0 with this. Oh wait, so this one isn't actually finished running yet, because, well, actually no, this one is finished running, but this one was on pause of 2, but then we still have to see what's on the next side of the equation, right? So 2 minus 2, get fib number of 2 minus 2 is 0, and that evaluates to 1, right? We just hit our base case, and we got the value back from that. We got 1. So then we can continue this equation in this. This is taken off of the call stack. So then get fib number of 2 can continue running. So we do get fib number of 2 minus 1. So now get fib number of 1 gets thrown onto the call stack. 1 gets passed in, 1 is less than 2, so we return 1 from there. So then get fib number of 1 is taken off, it returns 1, right? So this is taken off. So then get fib number of 2 has 2 values, right? It evaluated get fib number of 0, and it evaluated get fib number of 1, and those both things return 1. So then get fib number of 2 returns 1 plus 1. So it returns 2. And in the Fibonacci sequence, at the second index, you have a 2. So now that get fib number of 2 is returning 2, we can continue get fib number of 4, right? 4 minus 2 is actually get fib number of 2, and we know that this returns 2, right? But now we can do the other half of this equation. Get fib number of num minus 1. 4 minus 1 is 3. So 3 is now put onto the call stack. Do you see how long these things have been paused for? Because we're calling multiple functions now inside of one function over and over again until we hit our base case, right? So get fib number of 3 is now on the call stack. 3 is not less than 2, so we have to do this whole shebang again. 3 minus 2 will be 1, 3 minus 1 will be 2, right? So then we call get fib number of 3 minus 2 of 1, right? Before we can get to 3 minus 1, right? We have to do 3 minus 2 first. Do you see the pattern? It's going to take each number, call it repeatedly, until we're always subtracting, right? Until it reaches something that's less than 2. Then we actually get the return value, right? So then 3 minus 2 returns 1, right? So this returns 1. So we have 1 here. And then we're still running get fib number of 3. So then we have to do this side, right? 3 minus 1 is 2. So then get fib number of 2 goes on. This is like really repetitive, right? It's also really annoying to keep track of mentally. So then you call get fib number of 2. Get fib number of 2 returns 2, right? I don't have to walk you guys through that. We already established that. So if this returns 2, then this one will return 1 plus 2, right? Because if this returns 2, that's the two sides of this equation. So get fib number of 3 returns 3. So then get fib number of 4 returns 2 plus 3. So get fib number of 4 returns 5. And I'm not going to walk you through the rest of this problem on the call stack because it's getting too much. But do you guys see how there's a pattern? We're going to call it again, decrementing the actual argument we're calling it with, until this lone if statement up top is going to be get hit. Because when you call a function, when you invoke a function, that's an action, right? You're invoking it, so that's not a value. You need to find a value. So you go deeper and deeper until you get that value, pull it up, use it with this other thing that got another value, pulled it up. So if you think about it, get fib number of 6, it doesn't know like what this Fibonacci sequence is, right? It doesn't know what that is. It calls itself over and over again until it hits 1 plus 1. Until it gets the third number. So
in a way, it's just like we'll kind of hold 6 there and just goes back to like it doesn't have to do that.
pretty much. So the reason 6 is being held down here, get fib number of 6 is being held down here, is because it has to evaluate these functions first, which is get fib number of 4, and then I didn't even get there yet, but then get fib number of 5. And those things will take a long time to finish, right? Well, a long time to explain it to you step by step, like that, right? So since those functions are running, this one has to wait. It has to wait and see what's going to happen here, right? But again, if you don't do this with a base case, you get the error, right? Oh, I did the save. You get the error, right? Maximum call stack size exceeded. Because you never told it when to return something, when to stop. But I just wanted to show you another example of how you can use recursion and actually get a return value of use from the bottom and use it. Are there any questions? Any questions about the call stack or recursion? This is super confusing, so like tell me, you know? I'll try and help. Right. So essentially, so anything you can solve recursively, you can solve with loop, right? So that's one. So people often really do tend to use loops, but sometimes recursion, solving a problem recursively makes more sense. Like an example would be, let's say you don't know what kind of data is coming into your function, but let's say it's an object of arrays of objects of arrays of objects of arrays, right? But you don't know how many levels deep it will be. So you can call it recursively and tell it when to stop when you hit something that's not an object. Whereas if you were trying to use loops, it would just have to be, you would have to write a set number of for loops, right? to go into it over and over. So that's kind of the case. However, recursion is actually less memory efficient, if I recall correctly. So loops are actually more optimized, but if you see recursion as a possibility, so if you see it, like, you kind of have to know what's going on. So it's just important to know. And sometimes problems do make more sense to solve recursively. I can't really think of one right now, but any other questions? The Fibonacci thing got confusing when you started thinking about the call stack, but it made sense, right? It's calling two different functions. You have to wait and see what those things return. So over and over again, things are being put onto the call stack and then taken off of it. Put on, then taken off, and put on, until we get the final return value added together, right? Cool. Okay. So in this lecture, I'll go over again the definition of recursion, what the call stack is. I'll do the countdown example again, and then I'll show you a factorial example. And then I'll talk about recursion with arrays and strings, and then tips for approaching recursion problems. Okay? So recursion occurs when a function calls itself, and recursion is an alternative to iteration using a loop. In the real world, you may see recursion instead of iteration when a recursive solution is easier to reason about, because recursion does help break down bigger problems into smaller chunks. And it's easier to read than an iterative solution, right? Instead of writing a bunch of for loops and while loops nested, calling a function like once is cleaner code, right? And it won't negatively affect performance too much, but recursion can be a memory hog. So it's just something to think about. So machine learning, AI, and traversing through data structures, those are just some use cases for recursion. Don't ask me how recursion is used in machine learning and AI, because I don't work with machine learning or AI, so. Okay, so the call stack. JS is single-threaded, like I said, and that means that it can only run one function at a time, right? So the call stack is the structure that JavaScript uses to figure out which function it should be running at any point in time. So whenever we call a function, it's added to the top of the call stack. So this is like the thing I showed you, right? So here is a visual call stack. When first is invoked at the bottom, it gets thrown onto the call stack. First runs. Console logs, I am first. First is done running, it gets taken off of the call stack. Then when second is called, second goes onto the call stack. You see that second only went on after first was taken off. Because when a function is done running, it gets taken off of the call stack. So second is now onto the call stack, and second runs. Then when second's finished running, it gets taken off. Are there any questions on this? Anything? Cool. So, like we did before in this countdown example, we could just loop through. We could start I at the number, decrement it until we get to 1, and then we can console log I, so we'll get 5, 4, 3, 2, 1. Does everyone agree that we can do this? This is just a simple for loop when we go down and console log what I is each time. right?
Did I hit the wrong button?
Oh, I guess these slides are out of order. Okay, so let's talk about the call. Sorry about that. So let's talk about the call stack again before we go back to the countdown example. So in this, you see that function first is now a little different, right? It's a little different. Function first is actually calling function second inside of it. And before the call, we say I am first. Then we make the call. Then after the call, we say first is finished. And then second should console log I am second. So what happens when you call first on the actual call stack? First gets put on. So now JavaScript knows that first is running. I am first is the first thing that first runs, right? So console logs I am first. But then second starts running. It's called here, so second is put onto the call stack, and first is put on hold. Is everyone okay with that? So now that second is on the call stack, first is on hold, and we're going to run second. So I am second runs here. Then second is actually done running, so second gets taken off. And then since first was paused while second ran, we can now continue and make it to the third line. So first is finished, then gets console, and then first can be taken off of the call stack. It makes logical sense, right? Like a stack. Like you call the function, it goes there. If something else is being called before that's done, it's going to go on top and the other one gets paused. That's the main thing, right? That's the main logic to get behind the call stack, okay? So back to the countdown example. So let's refactor this solution, writing a function that takes a number and logs it out. So we could just call countdown 5 times with different numbers and then do that, right? But that's not really a program. You're not like doing something that will give you the same result no matter how many, you know what I'm saying? So how can we change this? Every time we called countdown, we subtracted 1 from the previous number. Instead of manually calling countdown over and over, why not have countdown call itself, subtracting 1 from number each time? So we call countdown with 5. So countdown with 5 goes on. So we get 5. Then we call countdown of 5 minus 1, 4. So countdown of 4 goes onto the call stack, right? So then countdown of 4 runs, and it console logs number. And the number is 4. So we get 4. Is everyone with me? So then we keep going. Countdown of 3, console log 3. Then countdown of 2. Countdown of 1. Countdown of 0. Countdown of -1. And this just goes on and on. Because you're never telling this function when to stop. And you're going to get this error that you get when you are in an infinite loop, because that's what you're in. It's an infinite loop of function calls. That started off so promising. Because our function was instructed to call itself every time, the function ends up calling itself forever until our computer runs out of memory. So let's write in a stop condition so the function eventually stops calling itself. Here's our stop condition, and this is commonly known as the base case, right? And here's our recursive case. So now, countdown of 3 is put onto the call stack. Is 3 less than 1? No. So we're going to console log it, and then we're going to run countdown again with 3 minus 1, so 2. 2 isn't less than 1, but 2 gets put on the call stack, right? 2 isn't less than 1, so we're going to console log 2, and then we're going to run countdown of 2 minus 1. Countdown of 2 minus 1 is countdown of 1, right? And then while this is happening, these things are never done. These things are still waiting to evaluate what that recursive call is, right? So countdown of 1, 1 is not less than 1, so now we're going to do countdown of 0. We console log done. So countdown of 0 doesn't hit this else, and undefined is returned by that function. So that function isn't running anymore, it returned undefined. So countdown of 0 gets taken off. And then countdown of 1 invoked countdown in 0, right? But since that finished running, countdown of 1 can finally go to the next lines. But there's nothing else, so it's going to return undefined. And then countdown of 2 invoked countdown of 1, but countdown of 1 just finished running, got taken off, and it returned undefined, right? So this was evaluated to undefined, and it continues going down. Down, and down, until there's nothing left on the call stack. And we already have what we wanted in the console, right? Are there any questions? Talk to me. Any questions on them? Yeah.
So, when it comes to this game, the function is done and not logged in. If you're placing console log,
Here?
yeah.
Yeah, you wouldn't see done in the console in white, but if you remember like in REPL, how in green it shows you the return value,
Yeah.
it would show done.
But then in the else statement, when you're putting in the long out stuff,
So you want to return number here?
yeah.
No, if you return number here, then this will never get called, right?
Yeah.
Because anything after a return statement is dead code, right? You just can't. It will never be reached. Unreachable code. If you wanted to return the function being invoked, this would still give you the same console. Just at the end, you'll get undefined. Or if you're returning done, at the end, you'll just get done. Because when you hit the base case and you're not calling it again, that value is pretty much passed all the way up. And I'll show you another example with return in the next slides. Okay? So 2 takeaways from that problem, right? You need to define a base case, and your recursive case must change the input to the function so that you will eventually trigger the base case. Those are the main 2 things when you're solving recursive problems. You have to have a point where to stop, and you have to make sure that that point will be reached. Okay? So let's talk about returning values from recursive calls. So recursion becomes more complicated when the function must return a value, and good practice is to start by defining the base case. Base cases often occur when there is a simple input that expects a simple output, right? So the sum of a number is that number, right? So test the base case can work before working with the recursive case. It's best practice. Just so you don't get caught in like infinite loops, you know? So, as a reminder, this is what a factorial is. If you want the factorial of 3, you do 3 times 2 times 1. And then you get 6. Same thing with 2 times 1, you get 2. 1 is just 1, 0 is just 1. 5, 5 times 4 times 3 times 2 times 1. It's the number times itself. It's the number times everything decremented by 1 up until 1. That's what a factorial is, okay? So what do you guys think will be the base case if we wanted to write a function that gives us the factorial of the number that we put in? Exactly. Because you know that the factorial of 0 and 1 is 1, without a doubt, right? That's just going to be 1. You don't have to do any calculation. So we can just tell it, we can just say like, hey, if this number is less than 2, we can just return 1, right? Just think about that. So what looks like simple, oh yeah, I just asked that question. So we can write our function factorial, and our base case will be if num is equal to 0, or num is equal to 1, or num is less than 2, whatever, you know? And if that happens, we're just going to return 1. So if you do factorial of 0 and factorial of 1, you get 1, right? Is everyone cool with that? This was step 1. Writing our base case, determining what it was mentally, writing it out and testing it with simple inputs, and we get simple outputs. Okay? So now, so the base case is set. Just need to remember that our recursive case has to bring the number closer and closer to 1 or 0, right? Because our base case is if the number is 0 or 1, right? So whatever, and we know that the function is going to take a number in, so we have to make that argument closer and closer to 1 and 0 no matter what it is. So how do we do that? We could do this, right? Well, this is what is actually going to happen recursively. So if we do 4, 3, 2, 1, right? So this is going to take the number times the number minus 1, right? It's the same scenario as before in the countdown. We have to decrement the recursive function call's argument by 1 before you call it, right? And that is how we will solve this problem. So if the base case number is 0, 1, we're going to return 1, right? So it's best to write your recursive case using the simplest possible input that will result in a recursive call. So if it's not 0 or 1, the most simple case you can call it with would be 2, right? It's just one number up. So if you say factorial 2, right now we're getting undefined because we're not doing anything yet, right? We haven't written the recursive case yet. So we can say right away, we can just test this out. We can call our own we can call this function recursively, sorry, with num minus 1. So if 2 is being put into it, this will be factorial of 1, right? So then we'll call it again, where num is 1, and then this is true, so this is just going to return 1. So that will be 1, right? But result is still undefined. There's a very simple reason to this. It's because we're console logging something. So if you're assigning this to a variable, the actual return value, like factorial of 2 isn't returning anything, right? Factorial of 2 returns this invoked. Well, not really. No, it doesn't return this invoked. It just calls this. It console logs this invoked, right? And the result of this will be 1 because that returns 1. So it just console logs 1 and that's it. It doesn't actually return a value. So it's still undefined and we still have work to do. So to get the correct factorial, because before we just proved that it gets 1, right? But we need to get that number times that. So to do this, now we will console log and we see that 2 is correct, right? So the num obviously gets closer to 0 if we were to call it again with a higher number, right? And from that pattern we noticed earlier, we know that 2 factorial is equal to 2 minus 1, 2 times 1, right? Is anyone confused? So to make this function actually work for factorial of 2, we just have to return the actual result, right? We have to set this equal to something and then return that, or return the whole statement as is. So when we console log result down here, we get 2. because factorial of 2, you call this number, num is 2. This if statement is not hit, because 2 is not equal to 0 or 1. And then it says let results equal, okay, 2 times the function being called. Factorial of 2 minus 1. And factorial of 1 is going to return 1, right? So it's going to be 2 times 1, and that's what's going to be returned in the result. So that means this result out here is now equal to 2, and that's why that's in the console. We cool? That's the most simple case. So now that we know that it works for 2, let's see if it works for 5, right? And let's do this little chart over here that'll show you what's happening and what the return value is at each time. So we call factorial with 5, right? We're setting it equal to, we're declaring that this is equal to results, a new variable, but that thing is actually an invoked function, right? So we have to run this function to find out what it returns. So factorial of 5 is put onto the call stack. 5 goes in here, it's not equal to this, but its return value is going to be 5 times factorial of 4. Does everyone agree with this statement? That when you call factorial of 5 is going to return 5 times factorial of 4. Does everyone agree? Who disagrees? Cool. So then, factorial of 4 is going to be put onto the call stack because you have to evaluate what that function is returning. What factorial of 5 is returning is 5 times factorial of 4. So then factorial of 4, what is that? We don't know. Let's find out. In the meantime, factorial 5 is no longer running anymore. Okay? It's not running, it's paused. And factorial of 4 goes onto the call stack, so we run factorial of 4. This if statement isn't true, and then this is going to return 4 times factorial of 4 minus 1. So does everyone agree that factorial of 4 is going to return 4 times factorial of 3? Right? And this goes on and on until we hit factorial of 2, right? Well, not until we hit factorial of 2, but we already know what's going to happen, right? Factorial of 2, once we decremented it enough, factorial of 2 here is now on the call stack, and that's equal to 2 times factorial of 1, right? That's what factorial 2 is returning. So then factorial of 1 gets put onto the call stack, and factorial of 1 returns 1. Base case hit, no more function calls. Once the function sees this return statement, everything else stops running. It's over. That's it. So 1 is actually the return value of factorial of 1. So then here, if this is the return value of this, then this is going to be equal to 2 times 1, right? Because factorial of 1 is actually equal to 1, right? So if this is 2 times factorial of 1, it's going to be 2 times 1. So factorial of 2 is actually going to be equal to 2. But we're not done with the call stack yet, right? We still have things on there. And we remember that factorial 3 is actually equal to 3 times factorial 2. But we just finished running factorial of 2, and we know that it returns 2. So factorial of 3 will be equal to 3 times 2. And then factorial of 3 is equal to 6. So factorial of 3 stops running, and we can just remove it from the call stack. And we can continue what was on pause below it, right below it, which is factorial of 4, which is equal to 4 times factorial of 3. So it's 4 times 6, sorry. So we have 24 as the result of factorial 4, right? So then now that factorial of 4 is finished running, we have our return value, we're done, there's no more function calls going on inside of factorial 4. we can say that factorial of 5 is equal to 5 times whatever factorial of 4 just returned, which is 24. And that is 120. Does everyone understand that? Yeah. If you do what?
Wouldn't you just want the base case to go to if none equals 0 because you want it to get one in index 0 because then it would be 1 plus
Wait, what are you talking about?
So in the base case,
Yeah.
it says if none equals 0 or none equals 1, wouldn't you want it to only equal 0 because
Well, the factorial of 0 and 1
is
is
equal
1.
to 1, but it's not getting 0 because it's finding 1 first and then it's ending.
But if the base case is just 0 and you throw factorial of 1, if you just patch it 1, you're going to make a recursive call that you don't need to.
Okay.
But
But with
factorial of 0 exists, so you have to take into account that that can be thrown in 2.
okay. What if you want like full Fibonacci sequence to be printed out or
No, we'll do factorial. This isn't Fibonacci.
I mean factorial if you want let's do
Well, we can't return 0, right? Because 0 times anything is 0. So if we return 0, that would be wrong, right?
Oh, okay, yeah.
Like, we don't want the actual number that was called. We just want its factorial value. And we know that the factorial value of 0 and 1 is 1. And then, if anything bigger than that, like 2, 3, 4, that will be every number in between 1 and 4, 1 and 3, multiplied together. That's what the factorial actually is. And this is how we solve it with recursion in this function. Does anyone have any other questions on how we got 120 as a return value? I think the visual helped, as in saying factorial of 5 is actually equal to 5, the number, times function call, right? 5 times factorial of 4. But since that was called, you have to put that onto the call stack, and it gets higher and higher until we get a return value. Then we can spit that return value back down the call stack as things get taken off, all the way back down until that's it. Then we get 120. What's up?
Wouldn't we return undefined 120 undefined?
What, are you saying why isn't it undefined? Or like when would it be?
120 and undefined.
What do you mean and undefined? That's because it's scroll down. Nothing's really returned. It's just constant logging the results. So like here, it's just constant logging. Feel me? So the reason why we get 120 as a return value is because we're actually going to return a result. We're going to return values. We're not just console logging things anymore. Because when you just console log, you don't implicitly return something. Explicitly return something. Undefined gets implicitly returned. Explicitly. You guys good? So there's 3 takeaways from factorial. Write your base case first and test it using simple inputs and outputs, right? I mean, that's best practice, but like if you're lazy, you don't have to do it. Well, yeah, do it, you know? Write your base case and test it using the simplest possible input that results in one recursive call to the base case. Make sure that you hit it calling it once. Like we knew that factorial of 2 was 2, right? So we knew exactly what was going to happen in that situation. So this is actually useful. Don't try and solve a problem recursively thinking like, okay, I have to make sure that this factorial question solves the factorial of 45. So I'm going to mentally sit here and think about how that would happen. No. Make sure you hit your base case first with the 2, okay? Make sure that's happening. Because if it doesn't happen, you could get bugs later on, and then you just won't really know what's going on. You know what I mean? So it's just best practice, and it'll make your life easier down the line. So, and then test your function against more complex inputs. So always define your base case. Make sure your recursive call will eventually trigger the base case by altering the argument. And test it using simple inputs and outputs, okay? Those are some tips. And you should try to use Chrome's debugger. It can help you inspect recursive calls because console log will not be as useful with recursion, but food for thought. So, you can use recursion with any data type in JavaScript, not just like numbers and adding things and multiplying things. So if you're asked to recurse through arrays or strings, the best case often occurs when the iterable has empty or a length of 1, right? So imagine finding the sum of numbers in an array. So the sum of 4, if array.length is equal to 1, the sum is 4, right? So imagine you're writing a function that has to take every element in the array and add it together, right? The sum of the array. If there's only one element in the array, the sum is that element, right? It's 4. So that would be a good base case. When the array's length is 1, return the element. So if the base case required the iterable to have a length of 1 or 0, it must mean that the recursive case has to reduce the length of the iterable with every recursive call, right? So instead of subtracting num minus 1, this minus this, you could do like array.slice of 0 to array.length minus 1, right? So you take everything off the array, so you get one thing, and then return that value. It'll kind of do the same thing. You guys understand? It's the same logic, except a different data structure. Nested arrays can be approached differently, and how do you deal with recursion with nested arrays and nested objects and arrays and objects and arrays or whatever? That's going to be recursion 2. That's all that recursion 2 is going to talk about in the lecture itself, okay? So in recursion 2, you won't be seeing any new surprises about how this is going to work. This is it, okay? But don't worry about multi-dimensional arrays with recursion right now. Yeah, so definitely start with the base case. That's number 1 for sure. Definitely do that, and test it with the simplest cases. Okay. You want to test it so that the actual recursive call is only running once, because then it's easier to debug. Why isn't this simple thing happening? You can fix that right away. And then ask yourself, what type of thing should my function return? A base case and recursive case should return the same type of thing, right? So if you want to get a return value from your recursive solution, if the function's asked to return a number, so should your recursive value, right? It doesn't make sense for it to return anything else. So that's also another way to mentally think about constructing your problem, constructing your solution. Use console logs or the debugger to debug. Honestly, console logging is fine. But if you want to try out the Chrome debugger, that can help too, because that lets you step through function calls. It's pretty interesting. So if you get stuck on a recursive problem, you can actually just try writing it iteratively, That's also a good way to calm your nerves a little bit, because how would you normally what would you normally do in a loop at this point in time? It's kind of like that. It can reveal the inner workings of recursion just to see how you normally would do it. That could help you if you want. Personally, that doesn't help me at all if I ever get stuck in a recursion problem. But it could help you. I've heard people tell me that. So we talked about recursion, the call stack. Did some examples, talked about how it can be used with arrays and strings as well, quickly, and some tips. How do you guys feel? It's not bad? Okay, take 5 minutes and then I'll open up the workshop. You you guys can get some hands-on experience using this stuff. Okay.